x equal to x. And you sub this kind of function into the system, into the differential equation, then you will obtain the same as my the teaching assistant had, which is here. He was using EG to convert it to a continuum model, that's exactly the same as your problem, the homework problem. And the second part, he just has the I have an I here, so that I if you the complex approach, teaching assistant use the it's also the complex approach, except he has A and B, A e to minus 0.4, I think 0.4. It's 0.4 upon 1. You can just use the exponential function like this complex, and set into the problem. Then you will be able to solve your problem much easier, because you use the exponential function. That's easier to do. Alright? And anyway, okay, he's up all the value in there, so that's okay. But anyway, that's you can use this I, complex I, to make your solution simple. And if you do that, that's exactly the same as in your note a few months ago, to solve the response of a system. And that's the solution. Solution is like that. Alright, that's the same problem. And I expect if you use this approach, I expect you can solve it in about 10 or 15 minutes. The number 4, that's an easy part, because it's just simple and algebraic procedures. You have x0, 10, 1, and this is the same as your homework problem, except now I ask you to solve it by hand. However, I use making your problem simple. I have only the post input. That means that the first input is 1, all the other input are 0. And that makes the problem easier too. Okay. So, 这个是用这个还用这个？这个。Okay, that's good. Alright. Yeah, okay, that's good. Alright. So, you just keep submitting to it, and then you get all the solution, just 4 steps. And that's the solution, 4 steps. Okay. Now another one, I have a G1 and G2, and solve the G1, G2, this is in the middle length here, but the solution, the final solution is this. G equal to minus 0.25625, the second one is 0.743763. And that's the solutions. If you sub this into the original square there, then you find out they are 0, 0, 0, 0. Okay. And the problem 4.3, just for you to get familiar with the observer. So how can you estimate state? So after the second step, 0, 1, after the second step, like 2 and 4, then you'll find out the state is exactly the same as your true state. Your true state is here. So that's your true state. So you will check x3, that's minus 9.45, and x hat 3, or x hat 3, or x hat 3 is minus 9.4521. So your state estimator did a very good job to estimate your state. state after second step because your G is a dead ball of 0. So that's just allow you to see what's going on. Alright, so this is also your homework problem. Okay, your homework is computer. Use your hand and then you might have some problem, right? Something like that. Are there any questions at this moment? Anyone here? 有没有问题？没问题都对哈，你们做的都对哈。Okay, congratulations. Alright, very easy, right? It's not difficult. Alright, so if you do your homework, then it will be easier. So next time, don't forget to bring your homework with you. And the problem 501 the problem 5 is even easier. This is exactly the same as your problem. I forgot either problem 3 or 1, 4, 5. I forgot about the number. Now, if you have a measurement W double dot, measurement of W dot, then I think my teaching assistant got it wrong here. Give me the W double dot, not the W nothing. So I think something is not right. Here, I think you have a measurement of W and W double dot here, right? You see the W double dot there? W double dot. You have accelerations and you have velocities. Now, if you have acceleration and you have velocities, then you can have an MC here, W double dot. And this MC, so you're supposed to go to M there, not to K. I think he did something not correct, but the same idea, the same concept. And if you do this and step into it, then you get your frequent response function omega. And then you can do it exactly the same as your homework to solve your damping. If I give you damping ratio, you can solve your damping when you solve your frequencies. So this is omega t equal omega a. Now, omega t equal omega n. Now this is KC, the MC this is supposed to be like that. Alright, I think something not correct here. Show here. Now, in matter of fact, now the real solution is this. The real solution is this. It's like that. W double dot plus KW equal to zeta W dot C plus MC W double dot. Okay, that's your solution. That's it. Now, let me see in here. So then I have this minus. Sorry. This minus here. This minus there. When you do that, then I have N plus MC double dot plus delta C double dot and then plus KW equals 0. That's my design. That's my cross loop. That's it. That's my cross loop. Everybody here is correct. 你水就对了，没有特别吧？这么简单啊？你想太远了 ，you think too much, I think, right? So, then WD design equal to WC equal to WN, the omega n, and that's equal to square root K over N plus MC. Alright? And that's your omega D. That's equal to that. Okay, that's one equation you have to solve. Then another one here, we have theta, and then from there you can solve this equal to square root K over N, because that's my omega n. Right? So from that you can solve the Kc, and you can solve your Kc, your MC, and you can solve your MC. So MC. Yeah. Right. Okay. And after solve your MC, then you can go back to solve your zeta, because I give you the damping ratio. You can solve that just like your homework, except now homework is W is now W double dot is W, and now here we have W double dot. Right? That's easy. I think this is pretty things to do. I just change a little bit your measurement device. Okay. Now, if you look at carefully, that in the last bullet, 5.4, I said the design may not be feasible in practice. I want you to make a comment. I say, okay, now, if I give you this kind of design, this is limited to, this is limited to this, right? This is limited to, I don't have a case here. I have the accelerometer, so I do have the n plus mc. Well, let me say this. So now the Milik equation, the Milik system will become like that. The Milik system is like that. This is my this is my 101, and I have K, and I have here N plus MC, then I have a damping like that, and I have this. And this is my letter C. Okay, that's my Milik system. Okay, but can I implement it in the 101? Well, it's very difficult if it's not possible, because I have to have a ground to attach to my desktop. My 101 here, this is my 101. Then how can I have another ground here to attach for my desktop? And so this is the questions. Can I design an assumption that